Hello, this is Lecture 5. Welcome back. We're going to be looking at decision structures today in Java for the next couple weeks. So this week we start in Chapter 3. The topics that are in this chapter are the if statement, the if-else statement, nested if statements, if-else-if, which is really a kind of a special case of the if-else and if statements, logical operators, comparing string objects. We'll learn more about variable declaration and scope, the conditional operator, switch statement, printf, the decimal format class as well. Today we'll focus only on some of those topics, and we'll finish them off next week. So, the if statement. The if statement decides whether a section of code executes or not. The if statement uses a Boolean to decide whether the next statement or block of statements executes. So the general format is if, Boolean expression is true, execute the next statement. This is a flowchart, which is a good representation of what occurs when you have an if statement. So what we've been used to thus far has been what we call sequential code. So we'll make a Java project. We'll call it Lecture 5 Examples. And once we have Lecture 5 Examples, I'm going to create a source file. Okay, we'll just call it Lecture 5 Examples also. Okay, and public static void main args. There is an option in Eclipse that you can actually just automatically fill in the public static void main, but I prefer typing it. I think it shows everyone that you should actually get in the habit of typing it. Eclipse is useful, and it's really handy and does a lot for you, but don't let it completely do everything for you. You want to get used to the actual syntax. Once you're extremely comfortable with this, then it would be okay if you wanted to just have it fill it in automatically. That's one of the options when you first create a Java file. It'll say include something to the effect of include the public static void main or include main. So what we've been used to thus far is we've had sequential statements. And then so we'll do system.out.print when and b is equal to b. So if I were to run this, as I expect, in the console we see that it says hello, A is 10, B is 20. Okay. Going back up to the code, we see that we have integer A set to 10, then B is set to 20, then immediately this is executed where it says system.out.println, and it prints out A with a little greeting, and then system.out.println B equal to something else, and this is all in sequence. So that just basically goes in a straight line. If we were to look at the if statement, however, there are many times when we don't want to just execute code in a straight line. We want to be able to decide between one situation or another. Now, the type of logic, or the type of math, essentially, that we'll use is Boolean. What this means is, ultimately, the only two values of a Boolean variable, Boolean statement, the result of a Boolean statement has to be true or false. That's what makes it Boolean. It's named after the mathematician George Boole. So if cold outside, this could represent a variable or it could be a condition in here, but we'll say it's a variable. If it is true, then it will execute the line immediately under the if statement called where code, which could be a method or something. So you'd say even in real life, in everyday life, you would have this little flowchart here. You have the code executing. You could have had sequential code maybe at the top. You go into the code and it says, is it cold outside? And then you have two options. If it is, if the answer is yes, you wear a coat. If the answer is no, you just continue executing. So you basically skip over the where a coat part. So if this, in code, if this is false, you do not execute this code. If it is true, you do. A block if statement may be modeled this way. Now, with a block if statement, you have to put curly braces around the block. If you have one statement, technically only you don't need the curly braces, but if you have any more than one statement, you have to put the curly braces. My preference is to always put the curly braces, even if it's a one-line statement. That's my own personal preference. So, but in this example, if we have a block of code where you have multiple methods or multiple sets of code that have to be executed, you come into the condition. Is it cold outside? That's the question, cold outside. If it is true, if that is true that it is cold outside, then that's yes. So you would execute wear a coat, wear a hat, wear gloves. Then you'd go along your merry way. Might run into another if statement, might run into a looping statement, which we haven't covered yet. Might just keep going until the end of the program, might immediately exit. But we don't know. We care at this point about this block of code, this section of code. If you ask the question, is it cold outside, and it is not, it will skip over all of these method calls. So if this is false, it will actually start right here and continue on. The curly braces, right here, if you hold down Shift and hit the key with the curly brace and the bracket on it, the opening bracket is directly to the right of the P. Then you have the closing bracket and closing curly brace on the key right next to it. So that's how you do a block if statement. Let's do a simple example. I will just do this. I will say int a int num equals 100. Say if num is less than 100, then I'm going to print out system.out.println num less than 100. Okay, so if I run it, it doesn't print anything. Well, why doesn't it? Because num is equal to 100, and 100 is not less than 100. So this statement is not executed. If I make num 80 and then run it, you'll note that it does print out num less than 100. Now, if I go back up here, you'll note that I could write an additional statement. Let's say that then the number is small. And let's look at this code for a second. Well, this is actually kind of confusing, because in an if statement, if you do not use curly braces, the if statement, the if clause, only applies to the immediate following line. The indentation that we added here has no meaning. It's just for readability, but this is actually confusing, because the number is small will always execute. So even if we make this number 150 and run the code, it'll still print out the number, well, it should be the number. The number is small. See, the number is small. If we go back up to the code, really what this should look like is more like that, because that is not part of the if statement. Now, if we want both of these inside of the if statement, then we have to do this. We have to put, we have really no option. We have to put curly braces around the code. Now they will both be acted upon by the if statement. So if it's 150, nothing happens. If it's 95, on the other hand, both of those statements will be executed, as we see near the bottom. So if we go back up to the code, that is how the if statement works. Now, even if I had one line of code that's to be executed, my personal preference, again, is to put curly braces around it. Also, some people do this. They put the curly brace on the same line as the if statement. I don't particularly like that, but that is a programming style preference, really, more than anything. Same thing with main. A lot of people put the curly brace up here on the same line as main. Something that will aid us in our usage of if statements, I actually showed you a second ago with the greater than sign, or less than sign. Yeah, less than sign. So these are called relational operators. They are all binary operators, meaning they all take two operands. So in this case, like we have with the code, notice that I had one number representing a value on this side, on the left side, of the less than sign, and then one number on the right-hand side of the value. So that's binary. It takes two. It doesn't mean it's working always with binary numbers. That's not what that means. But saying that it's a binary operator means it takes two operands. So you've got num is one operand on the left, and the right-hand operand is 100, the literal. These could be both variables. They could be both values. It could be anything. If we look back at the relational operators, we see that the Boolean expression is used by the if statement usually uses relational operators. So you'll have greater than, less than, greater than, or equal to. Notice there is no space between the greater than sign and the equal sign. Same thing with less than or equal to. And then you have the equality operators, which are is equal to. Notice it's a double equal sign, not a single equal sign. You have to put two for it to work correctly. And then not equal to is exclamation point equal. So these are the relational operators. When you're relating two different values, the result is a Boolean because all of these return a Boolean value. So num A is either greater than or not than num B. Num A is either greater than or less than or not num B, greater than or equal, etc., etc. They're either equal or they're not. So these are all different possibilities. These are examples. The Boolean expression is any variable or calculation that results in a true or false condition. X greater than Y is an expression. The meaning is X greater than Y, etc. I kind of went over that already, so I won't bore you with the details. If statements and Boolean expressions, these are some more examples. What this means is if the value in X is greater than the value in Y, then we want to print out X is greater than Y. Over here we have to say are X and Y equal? And then right here is a block of code. If X is not equal to Y, then you execute this line of code and this line of code and this line of code. So one thing we'll do is we'll do page 113, the example on page 113 in the book, if you're following along. We'll look at that, we'll call it average score. So inside of here, I'm going to create a new class, and we're going to call it average score. So we got our class here. We do need the J option pane, so we're going to import javax.swing.joption pane. Okay. Option pane. Oops, that P should not be capitalized. J option pane. All right. So public static void main string array args. Okay. Main. So I have double score 1, double score 2, and double score 3. Double average, which will calculate the average between the three, and then string input, which we will use to obtain input. So, get first test score. We're going to say input equals J option pane dot show input dialog. We're going to put enter score number 1. We're going to take that score 1 and we're going to use the double dot parse double on the input to return a double value. Then we're going to get second score. In this case, we're reusing the string variable, which is perfectly acceptable because we're just using it. We don't need a variable for each time we use the option, each time we use the show input dialog, unless we're trying to maintain each of the inputs in string form. In this case, we're not. So we'll say enter score number 2. We'll say score 2 is equal to double.parse double on the input, and then get third score. Input is equal to J option pane, show input dialog. Enter score number 3. I'm going to say score 3 is equal to double.parse double on input. Finally, once we do that, we're going to calculate the average by taking the sum of score 1, score 2, and score 3, and then dividing it by 3. So we have the average now. So now, display average score. This time we're going to use the J option pane a little bit differently and use it to show a message dialog this time. The average is average. And then we're going to use if statements. So we're going to say if average is greater than 95, what do we want to do? Well, in the book they do not put the curly braces, but I'm going to put the curly braces because I think that's a little more appropriate. It's better. It's a good habit to get into. You don't have to worry about one line being applicable or not. You just know that anything inside the body is going to only execute if the if statement is true. So for this particular one, if the user puts numbers in such that they average to be greater than 95, it will put an additional. It will show an additional J option pane that will say that's a great score. So let's run it. Let's run it and see what we can do. Okay, so score number 1, we'll put in, we'll say 82, put in 77, and 65. Okay, so give us the average, and then the program terminates. Well, you notice it did not execute the show message dialog that says that's a great score. It's because the average was not greater than 95. Well, let's put in this average. We'll put in 100, put in 98, and then a 93. Let's see what happens. It gives us the average is 97, and then it says that's a great score. So that's all we really need for that one. So the next thing we're going to look at is programming style. An if statement can span more than one line. However, it is still one statement. This right here is functionally equivalent to this. The compiler doesn't care. Okay, the compiler really doesn't care. But humans do. So it's good style to write the if statement, the header of the if statement here, and then the line after it, or a curly brace. Well, a curly brace could be on the same line, but any of the code inside the block of the if statement, or if you don't have the curly braces, regardless, they should be indented a tab character at least. So, and also notice there is no semicolon at the end of the header of the if statement. If you put one there, it will not apply this if statement to here, okay, to the actual code that's supposed to be in the block. It will assume you want to fill in a null statement, which means there's nothing to execute. So block if statements are when you have the curly braces. Remember that when curly braces are not used, then only the next statement after the if condition will be executed conditionally. So in this case, when you have if expression, statement 1, 2, and 3, if the expression is true or false, it will only apply to statement 1. 2 and 3 will always execute in this case. The next thing we'll talk about is flags. A flag is a Boolean variable that monitors some condition in a program. When a condition is true, the flag is set to true. The flag can be tested to see if the condition has changed. So if we have if average greater than 95, you might set a Boolean variable high score equal to true. Then later, the condition can be tested. So you might say if high score. Now, since high score is a Boolean variable, in this particular case, we're not having to compare it using any of the relational operators to any other Boolean variable. A Boolean variable in and of itself is true or false, so therefore it is an appropriate parameter to the if statement, for the header of the if statement. So if the high score is true, meaning that the average was greater than 95, the system will print out that's a high score. You can also test characters with relational operators. Characters are stored in memory using the Unicode character format. We have to understand that characters are not stored as characters in memory. They're stored as numbers. Unicode is stored as a 16-bit number. Okay, so it's 2 bytes, right? Characters are ordinal, meaning they have an order in the Unicode character system. Since the characters are ordinal, they can be compared to each other. So I might have char C, the name of the character, the identifier is C, but it contains the character A. That's why there's single quotes, because it's a character. So this is the data type char that we looked at briefly last couple weeks ago or last week. If the value that's in this C here is less than Z, meaning if it comes before it, it will print out A is less than Z. So the if statement that we looked at before either does something or it doesn't. It's what we call a single selection structure, or single selection control structure or control statement. The thing that we need to keep in mind is that sometimes we want to pick between multiple items. We want to pick between many different items. So in that case, you would use an if-else statement, or for one or the other item. Okay, in this case, it's one or the other. This is called a double selection statement because if this is true, if the expression is true, you do this. If it's not, you do that. So it's one or the other, and you're explicitly saying do one or the other. This is what the flowchart for an if-else statement looks. So is it cold outside? If the answer is yes, you want them to specifically wear a coat. If it is not, you want them to wear shorts. Either way, they will continue moving on afterwards. You can also nest if statements. Nested if statements are very useful in some scenarios. If an if statement appears inside another if statement, single or block, it's called nested. The nested if statement is executed only if the outer if statement results in a true condition. So this is what a nested if statement flowchart might look like. You have the outer if statement, which is it cold? If it is not, then you just wear shorts and then go away. But if it is, then it looks like there's another if statement inside of that code block. In this case, it asks another question, is it snowing? If it is not, wear a jacket. If it is snowing, wear a parka, and then continue on your way. So this is a nested if statement. So this is what the above code looks like. Cold outside would be, in this case, a flag or a Boolean. You could also have a comparison going on here. If it is not cold, then it goes to the else section here, and it calls wear shorts. But if it is cold, then we have another set of if-else that we have to compare. If it is snowing, wear a parka. If it is not, wear a jacket. Okay, so we'll do a nested example real quick. I'm going to right-click here, and then we're going to call this lone qualifier, like they have in the book. All right. Again, we're going to import javx.swing.jOption pane. So we could use the jOption pane. Public static void main string array args. Okay, inside of here, we're going to make the salary. This is, again, on page 123 if you're following along in the book. I just want to see what is going on here. I'm leaving out many of the comments and changing some of the programming style, possibly. because my programming style might be different. Get user annual salary. So again, the J option pane show input dialog. Okay, enter your annual salary. The show input dialog only returns a string. So we have to get that in string format. That's why we have the input in string format. Salary, on the other hand, we can take the salary, say double parse double, and then you're going to parse the string into a double format, so it can be stored inside of salary. Then get number of years at the current job. So what are we going to do? This time we're grabbing the answer again. Show input dialog. And in this case, you're going to say enter the number of years. You probably want something more descriptive like enter number of years at current job, but we'll go with this right now. Years on job equals double.parse double, and we pass it input again. So this time it's going to get the double representation of what they input. And now, determine whether the user qualifies for the loan. So, to qualify for the loan, they need to have a salary greater than $30,000. That's the first requirement. And then if they make greater than or equal to $30,000 a year, they also have to have been on the job 2 years or greater. So here's how we'll put the if statement. If salary is greater than or equal to 30,000, okay, put an else statement. We'll say in the outer else, okay. Then inside of the else statement, which is simpler because that just means they didn't make the cut as far as making enough money. So we'll say a message will say you must earn at least $30,000 per year to qualify. This is say a special interest rate loan or something. So we've got that. Also, just so we don't forget, we put system.exit, because when we use a J option pane, we have to put the system.exit. But here's where the nesting comes in. If they do make greater than or equal to $30,000, that is not sufficient for them to get the special interest rate or loan qualification. You want to put if years on job is greater than or equal to 2. Okay, and then also that has an else section, and inner else. Okay, if they do have greater than or equal to 2, then you're going to put J option pane message show. I'm sorry, option pane, not option message. Pane dot show message dialog. And put null, and then you qualify for the loan. That's a yay. Otherwise, J option pane dot show message dialog. You're going to put you must have been on your current job for at least 2 years to qualify. Right? So that's pretty good. Let's run it and see what happens. Okay, well, let's say they only make $25,000 a year. So we got 2 years. You must earn at least $30,000 to qualify. So it terminates then. All right, well, let's say we get a raise. We got $32,000 a year, so that's satisfied, but I've only been on the job 1 year. You must have been on your current job for at least 2 years to qualify. And then finally, let's say, okay, well, we make $50,000 a year, and they've been working for 10 years. says you qualify for the loan. All right, so this is the code for loan qualifier. The next thing we're going to look at if-else matching. Curly brace use is not required if there's only one statement to be conditionally executed. However, sometimes curly braces can help make the program more readable. Additionally, proper indentation makes it much easier to match up else statements with their corresponding if statements. So this is an example. This if statement lines up with this else statement. You'll notice that the indentation really helps with this, because we can see immediately that these two are together. And then we have another set of statements if we want to do... Okay, so the if-else if statements are for the purpose of if we have more than just do it or don't do it. If we've got other expressions to consider, for example, if we want to test expression 1 and another expression, instead of just having a catch-all default, which is just an else, you can keep going with this and keep chaining them. And then at the end, you could put just an else statement with no if, and that will be kind of like the default or the catch-all, like if none of the other if statements satisfy the condition. Okay, so nested if statements can become very complex. So the if-else-if statement makes certain types of nested statements a little bit cleaner. So it makes it a little bit nicer, can be a little bit more user-friendly and reader-friendly when you're looking at the code. This is what an if-else-if flowchart looks like. You go in here, let's say the score is less than 60. If it is, then you set the grade to F and continue along your way. If it's not, then you say, oh, well, is the score less than 70? If that's true, you give them a D and go on their way. If it's false, you continue to test this and keep going. So next are logical operators. These are extremely important. These are different than the relational operators. A lot of people confuse the two by their names, but relational operators are relating two values. Logical operators allow you to combine two binary statements or reverse the truth of a Boolean expression. Not binary, I'm sorry, a Boolean expression. You can combine Boolean expressions, or you can reverse a Boolean expression. So here are the logical operators. You have the AND, logical AND, which means that both expressions have to be true for the overall expression to be true. So that means if you have A less than B and C less than D, then that means that A has to be less than B. If that's true, then and C has to be less than D for the whole statement to be true. Otherwise, it won't work. So, AND requires that all of its operands be true, or requires only one or both of the expressions to be true. It's only necessary for one to be true, and it doesn't matter which one. Okay, so if either of the statements are false, or expressions are false, then AND will cause the whole statement to be false. With OR, if one of them is false and one of them is true, it doesn't matter which one. As long as one of them is true, then OR returns true. Not is a unary operator. That means that it only takes one operand, not two like the other two. That means it will reverse the truth of a Boolean expression. So if you have a result even from one of the series of these, or just a plain old Boolean variable, if you put a not in front of it, it reverses it. So if the variable or expression evaluates to true, and you put a not in front of it, it will be false. If you put a not in front of a false, it'll become true. Here are what we call the truth tables for the AND operator. Logical AND takes two operands. and they must both be Boolean expressions. That's one difference between the Boolean and the relational operators, that the logical and the relational operators, that the logical operators have to take Boolean operands. So the resulting combined expression is true if and only if both operands are true. So the truth table shows us if expression 1 on this side and expression 2 are this way, if you've got true and false, the whole thing is false. If you've got false and true, the whole thing's false. Both are false, the whole thing's false. The only occurrence when the whole statement is true is when both expressions that make up the statement the expression are true. So we'll go with an example here. We'll create a class. We're going to call it logical and. All right, logical and. Going to, just to show you can do it, I could check that and it would actually add the main method for me. So for this one, we're going to use JOption pane again. So I need to go to the top, import JAVX swing, JOption pane. Alright, so you've got the main method. I'm going to take double salary, double years on job, and string input. Okay, so string input, and then you get the user's annual salary. Input equals JOption pane dot show input dialog. So you enter your annual salary, and once we get the annual salary, then you can convert it. Salary equals double dot parse double, and then get number of years. And input equals JOption pane dot show input dialog. Enter number of years. Okay, then we have years. I'll put these closer to each other so we can see where they come from. Years on job equals double dot parse double input. Determine whether user qualifies. Okay, so this is doing essentially the same thing we just had, but we're going to kind of compact it using the logical operator. So if the salary is greater than or equal to 30,000 and years on job is greater than or equal to 2, then we put a JOption pane dot show message dialog, and if you qualify, and then otherwise JOption pane dot show message dialog, you do not qualify. Okay, so let's see if this makes sense to us. And means that, and requires that we. Sorry, I think I had my mic up for a second, unfortunately, so I will explain again what I was doing. After I typed all this, we get the user's annual salary here, and then we get the number of years in the corner, or underneath. So we get the number of years, and then we determine if the user qualifies. We have to determine, using this logical and, does this do what our previous version with the nested statements does? Salary greater than or equal to 30,000, that was a requirement, and they're also supposed to have been on the job for 2 or more years. So we also have years greater than or equal to 2. Now, let's ask the question, does and satisfy that condition that we need both of these to be true? In fact, that's the very definition of and. It says that both of its operands, which are Boolean expressions ultimately, this is Boolean because we're using the relational operator here, and we're using a relational operator here. So that means that if this whole statement is true, in other words, if the salary is greater than or equal to 30,000, and also the years on the job is greater than or equal to 2, then we say you qualify. Otherwise, if either of these is false, let's say that this first one's false, the salary, say, is 20,000, then this will automatically be true, and it won't even, in fact, it does what's called short-circuiting, and it will not even bother testing this right here, because it'll know and has to have both true. If we come across a false immediately, then why do we even bother testing the second one? Well, you don't. The compiler, the runtime environment compiler does not, the runtime environment executes the compiler, and then we will see, executes the program after the program has been compiled. Geez. And then we will see in the console, that's the word I was trying to get out, on the console, we will see you qualify if both of these are true, but if this one is not, then the runtime environment will take this right here and say, oh, that's false, and it's followed by an and, so that means that since this is already false, I don't even need to check this part. That's what we call short-circuiting. Then you go to the second section down here. Okay. Now let's say this is true: salary greater than or equal to 30,000, and years on the job is greater than or equal to 2. If years on the job is not greater than or equal to 2, but the salary say 50,000, this will be false. So then it'll be like true and false. If that's the case, it'll go to the else statement. Let's with a block of code under else. Let's say it's 25,000 and they've been on the job 5 years. It'll say you do not qualify. Doesn't really give an extra reason, but let's say 30,000. They make 30,000. Number of years is 1. It'll say you do not qualify. Number of years wasn't enough. Okay, let's say 35,000, and they're on the job for 5 years. You qualify. Okay, so this does exactly what it did with the nested statements, except it's a lot more compact and a lot cleaner. It's exactly what we want, so that does make sense. In this case, let's say if this expression 1 over here would have been, is the salary greater than or equal to 30, and then expression 2 is the years on the job greater than or equal to 2. For the OR statement, the logical OR takes two operands that must both be Boolean expressions, just like AND. The resulting combined expression is only false if both operands are false. So in other situations, the resulting expression is true. So true or false is true. False or true is true. False or false, this is the only occurrence where if they're both false, then it's false. And then true or true is true. All right. The not operator, the negation operator, or the not operator performs a logical not expression or operation. If the expression is true, then not expression will be false. If the expression is false, then not expression will be true. So for example, if not temperature less than 100, if temperature less, let's say the temperature is 101, if the temperature is 101, this will be true, right? So then when you say not true, that's false, so that means this will not execute. If the temperature is 90, 90 is not greater than 100, so that means it'll evaluate to false. Not false is true, so that will execute this particular statement. And like I said, short-circuiting, logical and or perform short-circuit evaluation of expressions. With logical and, it'll evaluate to false as soon as it sees one of its operands as a false statement. Logical or evaluates to true as soon as it sees one of the operands as a true statement. Because with logical or, let's say the statement with logical or, if you end up in a situation where you have the first statement is true, do we need to check the second statement? The answer is no, because if we're using logical or, that means that it only needs one of its operands to be true, so it does not matter if the second one is true or not. So that means that this will short circuit to true and short circuits to false. There is also an order of precedence, which we'll get to in just a minute. I'm going to take a quick break, and I recommend you do the same, and we will be back to this in just a moment. Alright, so order of precedence. The not or negation operator has a higher order of precedence than the and or operators. this means that they will be applied, that the not operator is applied first. So the and or operators have a lower precedence than relational operators, like less than or greater than, which is one of the reasons we're able to get things to work. If we have code like this, where we have salary greater than or equal to 30,000 and years on job greater than or equal to 2, obviously we want these with the relational operators to evaluate first and then to evaluate the and. Parentheses can be used to force the precedence to be changed, of course. Parentheses have the highest precedence. So this is the order of precedence. I won't go over this too much, but you have unary negation all the way down, and then you end up with the assignment and combined assignment operators down here. Another topic, as we get into the get it more into strings, are comparing string objects. We used a little bit of we did a little bit with strings recently, but you can't use relational operators to compare string objects. Instead, you have to use a string method. So reference variables can contain the address of the object they represent. So therefore, if you use the equals, double equal sign, which compares two sets of which compares two values of the same type. If you use them on two strings, then what you're going to get is that you're going to get a situation where the one string object is pointing to a particular area of memory, and the other string object pointing to a particular area of memory. And if those addresses are not the same, then they will not be equal, regardless of whether the value of the string is the same. If they both contain the name John, they will not necessarily return true if you use the double equal sign, which is the comparison equality comparison operator. So they do give a couple examples in the book with the compare, string compare, and then compareTo. We'll do, yeah, let me look here. No, compareTo is a little bit different. That's when you're trying to determine if one is lexicographically in the order or not. We'll start with compare. I think that makes more sense. We'll do compare. Okay, so we'll right-click this, go to class, and we'll call this string compare. Okay. I'd made a couple bad notes, unfortunately, so that's why I got thrown off. Public static void main string args. Okay. Inside of here, we're going to have string name 1 is equal to Mark. String name 2 is equal to Mary, or no, Mark. We'll make that Mark also. And then string name 3 is equal to Mary. Right? If name 1 dot equals name 2, then we want to say system dot out dot println. We want to say name 1. Oops. I'll say name 1 and 1 second. Sorry. Need to concatenate those. Okay, name 1 and name 2 are the same. That's the first if statement. I'm going to say otherwise. We're going to print out system.out.print line. I'm going to say name 1 and name 2 are not the same. All right. Next, we're going to compare Mark and Mary. If name 1 equals name 3, we're going to put system.out.print line name1 and name3 are the same, else name1 and name3 are not the same. Alright, there's our if statements and our else statements. The first one we're compare Mark to Mark, so they should be the same, right? So we'll run it, and as we expect, it says Mark and Mark are the same. Mark and Mary are not the same. Okay, I need to put an extra space there, make it good, but there we go. Mark and Mark are the same. Mark and Mary are not the same. So Mark and Mark are the same, Mark and Mary are not the same. This is because it's comparing them lexicographically. It compares the first two characters, and then it says, oh, those are equal. It goes on to the next two. Oh, those are equal. Oh, those are equal. And if, in the case of Mark and Mark, it got to the end of both strings and all the characters were equal, so it determined that the whole string is equal. But Mark and Mary, it gets up to MAR, those are all equal, but then when it gets to the K and the Y, it realizes that the K and the Y are not the same character. A similar thing that you can do is in the compareTo. What compareTo does is it's another method. It's not. It's different than the equals, and what it does is it determines if one string is quote-unquote greater than another. So the string class provides the compareTo method, which is used to determine if one string is greater than, equal to, or less than another string. So if the equals is not enough, then you can call compareTo. You have string.compareTo passes the other string. If the return value is negative, then that means that the string referenced by string, string that's calling compareTo, the calling object, is less than the other string argument. If there's 0, the two strings are equal. And if the method's value is positive, then the string referenced by the calling object is greater than the other string argument. So we're going to take a look at that. We've got Mark and Mary, which are name1 and name3. We'll take a look at that down here. We'll say using compareTo. Let me do this. We'll say if name1.compareTo, the other string we're comparing it to is name3. If that returns a value that's less than 0, in other words, a negative value, remember what the negative value means. That means that the name1 is less than name3. So we're going to put system.out.println. We're going to put that name1 is less than name3. Right? Then we're going to say else if name1.compareTo name3 is equal to 0. If that's the case, then we know that the two are equal. So we're going to say name1 is equal to name3. Right? So there we go. I think I put a colon instead of a semicolon. Else if name1.compareTo, we're going to compare it to name3, and then if it's greater than 0, we know what that means. We know that that means that the name1 is greater than a name3. In other words, lexicographically greater than. So we're going to say system.out.println name1 is greater than name3. Okay. So if we run this, we see at the end that it says Mark is less than Mary. Now, why is it less than Mary? Because the K has a smaller value. In other words, it comes earlier in the alphabet than does the Y in Mary. So Y has a greater value for the Y. than Mark does for the K. Now, for the M, the A, and the R, if any of these letters had varied, they would have been based on that. But since these are identical, it has to keep going through the string until it finds two letters that are not the same, and then it works off of those. So in this case, the K and the Y are the only two that are different. The Y is greater than the K, so it says Mark is less than Mary, which is pretty much what we expect. There's another thing that you should know. I don't believe they put it in the slides. Oh, no, here they do. Okay. Ignoring case and string comparisons. In the string class, the equals and compareTo methods are what we call case sensitive. In order to compare two string objects that might differ in case, you might want to use equals ignore case or compareTo ignore case. So you can, it doesn't matter if they have completely different case or not. You can call these one of these two methods to determine to compare them or to see if they're equal. Okay. The other concept that I want to cover before we another concept I want to cover that's important is variable scope. In Java, a local variable does not have to be declared at the beginning of the method. You should, most of the time, do this, but it doesn't have to be. The scope of a local variable begins at the point it is declared and terminates at the end of the method. Okay, it's considered a local variable if it's inside of a method. So if we have if we have a variable declared, for example, in the method main, we have string name 1 equals Mark, then that string right there, name 1, is going to be done at the end of the main method, which is down here. Okay, so that means that it is no longer in scope. When a program enters a section of code where a variable has scope, that variable has come into scope, which means the variable is visible to the program. If it is not visible to the program, it is considered out of scope. The next thing I want to go over, this is an optional section in the book, and this one's, I wouldn't say that I use this very frequently. I would say, excuse me, I would say that the conditional operator can sometimes be useful, but it's extremely hard to read. So you can use the conditional operator to write a simple statement that works like an if-else statement. So you can use this conditional operator, which is actually Java's only ternary operator, meaning it has 3 operands. And you might think, well, how the heck does that work? Pretty well, but it's kind of confusing as far as for people reading it. If they're not really familiar with the conditional operator, then it throws people off. And a lot of people don't use that. You'll notice in the book where it says optional next to it, that's because some instructors don't even like it. I'm not a huge fan of it, but you will probably come across this at some point, so I figured it'd be important to show you. The format of the conditional operator is, notice it's got actually 2 operators, 2 parts of it. You've got the Boolean expression at the beginning, so x greater than 10, string A dot equals string B, whatever results in a Boolean expression. Then you have a question mark, and then the value if true is right here, and then a colon, and then the value if false. Okay? So here's an example. You can set, we'll say that z, which is an integer, okay, not a Boolean, it is an integer here. We could say that z is equal to, now here's the condition, x greater than y. If x is greater than y, then, if that's true, then it'll store 10 in z. If it is false, it'll store 5 in z. So this line is functionally equivalent to this, okay? If x is greater than y, z equals 10, else z equals 5. All right? So it's very writable if you understand how it works, but it's not very pretty. So I don't typically use it. It's very hard to read, and with all these symbols everywhere, sometimes to a lot of people it looks like gibberish. Ternary operator, meaning it has the three operands, 1, 2, and 3. So that does tend to add more symbols, and it causes people to get confused. Okay, so many times the conditional operator is used to supply a value, so it often returns a value like I just showed. For example, x greater than y, return a 10 or a 5. They do have an example. I don't need to go over that. No, it's fine. But if you have any questions about it or want to see more examples of the conditional operator, I will be glad to provide them. It's just, it's not necessary to accomplish any of your assignments or anything, but it is just another way to use Boolean expressions in supplying values. So, well, that's it for today. We'll start with the switch statement next week on slide 41. So if you have any questions, please feel free to contact me, jpbaugh@oaklandcc.edu, or feel free to participate in the discussion boards. I strongly recommend you participate in the discussion boards. If you have any questions about your test, or not your test, your project, that's, I believe, is due very soon. We can look here just to double check here. Programming Project 1 is due next week on Valentine's Day. Happy Valentine's Day. Because you love getting assignments and doing homework so much, that's why I made it due that day. Not really, it's just where it fell. But anyway, after that, on next week we'll cover more on decision structures. We'll finish that out. Then we'll start on loops and files, which is chapter 4. We'll work on that, and I will assign program project number 2. And then I will also give you a little bit of review for your midterm. You will have midwinter break on the 24th, and then you'll have midterm. Days and times will be announced. That means I will offer different times you can come in to take your midterm. I will try to do what we can. If you absolutely cannot make any of the times that I would be available, then we will have to work out something for you to take your test. If you're really far away, sometimes we end up with students who are very far away. We'll have to get it proctored somehow. Okay, it means we have someone else making sure you're not cheating. So if you have any questions, again, please feel free to email me or contact me on the discussion boards. Feel free to interact with other students. Just don't do everyone's homework for them. That's basically the main. That's what I consider cheating, is if no one's learning and everyone's doing the homework for each other. So that's not good. All right, so thank you and have a great day. Bye-bye.